All right, so we are looking at multiplying polynomials, and we're going to start with a problem that may look familiar with the work that we did previously with distributing. So we have here 2t being multiplied to, in parentheses, 4t minus 3, close parentheses. And we see that we're distributing the 2t over subtraction. That's how we know it's distributing, because it's multiplication over addition or subtraction. So here I can see we're going to multiply the 2t to the 4t. So we know that we can multiply the 2 and the 4 to get 8. And the t times the t, remember when you are multiplying, you add your exponent. So that's t to the first power times t to the first power. So we have t squared. All right, so now we are distributing the 2t to the minus 3. So here we're going to have minus, and then multiply the 3 times the 2 to get 6, and then t. All right, so why don't you all try one here? We'll do the one here at the bottom of the screen, the negative 5r squared s squared times, in parentheses, negative 2r squared plus 3rs minus 4s squared, close parentheses. So go ahead and pause the video, try this on your own, and then we'll do it together. Alrighty then, so again, we are distributing this negative 5r squared s squared across addition and subtraction. So we'll first start with multiplying that to the negative 2r squared. So we'll simplify the negative 5 times the negative 2 gives us a positive 10. Now the r squared times the r squared, add your exponent. So we get r to the 4th power and s squared. Next, distribute the negative 5r squared s squared to the positive 3rs. All right, so that's going to give us negative 5 times positive 3. So that's minus 15. R squared times r to the 1st power, add your exponents. So we get r cubed. And then s squared times s to the 1st power, again, add your exponents. So we get s cubed. And then lastly, we distribute the negative 5r squared s squared to the minus 4s squared. So multiply the negative 5 times the negative 4, so you get plus 20. R squared, and then multiply the s squared times the s squared, add your exponent, so we have s to the 4th power. All right. And that is our final answer. So you might be thinking, well, why don't we combine like terms? Well, remember, in order to have like terms, you have to have the same variables, and those variables have to have the same exponent. So r to the 4th and s squared, there's no other term that has that same combination. Now, the last term has r squared and s to the 4th, but they're not the same. All right, and then obviously r cubed and s cubed is not the same as any of those other ones. So let's try another one here. We have negative 3a squared, parentheses, negative 4a squared plus 2a minus 1/3, close parentheses. So again, you see we're distributing the negative 3a squared across addition and subtraction. So go ahead and pause the video, try that on your own, then we'll do it together. Please don't be afraid of the fraction. Just write your work out, show your work, you can do this. All right, so we are distributing the negative 3a squared first. to the minus 4a squared. So that's -3 times -4, that gives us positive 12. And then a squared times a squared. Add your exponents, a to the 4th power. Next, distributing the -3a squared to the plus 2a. So the -3 times the positive 2. So we have -6. A squared times a to the 1st power. Add your exponent. So that's a cubed. And then we're distributing the -3a squared to the -1/3. Okay, so you want to multiply the -3 times the -1/3. We're going to have positive. Now let's show the work for that. So we have 3 times the 1/3. Okay, or in other words, you can think of the 3 as 3 over 1. So sometimes it's helpful for you to just say 3 times 1 gives you 3, divided by, and then 1 times 3 gives you 3. 3 divided by 3 gives you 1. That's one way to look at it. Or I would have preferred if you would have did the 3 over 1 times the 1 over 3, if you reduce that from the beginning, so you have 3 divided by 3 reduces to 1. So essentially you just get 1 over 1, which obviously equals 1. So either way, we have 1 and we still have that a squared. We're not going to put 1a squared because the 1 is implied. We just need to put a squared. So we have plus a squared for our last term. And that is done. All right, so for each of these, we were multiplying one term across a polynomial. So one term is a monomial. We multiplied a monomial across a binomial in letter A. And then in the second two examples, we multiplied a monomial, which is one term, across a trinomial, which is 3 terms. Now we're going to take a look at multiplying binomials, 2 terms times 2 terms. So one thing that I like to use as a reminder, as a helpful guide, whenever I'm multiplying a certain number of terms, in this case is 2 terms, multiplied by 2 terms, that 2 times 2 tells us we should have 4 terms when we first finish multiplying. That's before we simplify. So that's helpful. Okay, so here I have the parentheses 9 minus a, close parentheses, parentheses, a plus 4, close parentheses. So here I can see I'm multiplying the first set of parentheses to the second set of parentheses. And this still means that we are distributing. We're distributing first. We'll start with the 9, and we'll distribute the 9 to the a and to the plus 4. So you can think of it like this, as doing 9 times the a plus 4 first. So that gives us 9a plus 36. Okay. What about the minus a? We'll distribute the minus a to the a and to the plus 4. So it's kind of like if you write this, minus a, parentheses, a plus 4. So that gives us minus a squared minus 4a. Hence, let's count up the number of terms. 1, 2, 3, 4. We have 4 terms. Now, we're not done if we didn't simplify as far as we can go. So we look at this, we can simplify. And we can simplify by combining like terms, which I am going to abbreviate here on out. using CLT. Okay, so combining like terms. Our like terms will be the 9a and the minus 4a. They have the same variables with the same exponent. So I'm also going to write my answer in standard form, starting with the minus a squared. Then the 9a minus 4a. Remember, you want to add or subtract your coefficients, not the variable. So I'm doing 9 minus the 4, which gives me 5. So I do plus 5, and that's a. And then bring down the plus 36. And there's our answer. All right, now some folks may have learned some of this before, and even on your homework, it might make reference to this term referred to as FOIL. So the order in which I multiplied essentially uses the FOIL. So if you think about this, F stands for first, O stands for outer, I stands for inner, and L stands for last. So it tells you the order in which to multiply your binomial times your binomial. So if I look at, I multiply the 9 times the A. Those are my first terms. And then when I multiply the 9 times the 4, those are on the outer part of the problem. Then when we multiply the minus a times the a, those are on the inner, they're written inside the problem. And then when you multiply the minus a times the 4, they're each the last of their parentheses. So there's your FOIL that you're achieved by the arrows in the order I write the arrows. So if you like FOIL, feel free to use it. I don't refer to it much because it's implied in the way that I draw my arrows for these type of problems. So let's take a look at the question on the right here. We have parentheses, 3a plus 4, close parentheses, times parentheses, 3a minus 4, close parentheses. So go ahead and try this one on your own, and then we'll do it together. All right. So again, if you are foiling, that's fine. The arrows achieve that same method. So it will be like, here's distributing the 3a to the first. And then here's your outers. So essentially, we're saying 3a multiplied to the 3a minus 4. So that's going to give me 9a squared minus 12a. Wonderful. That's half the question. Now the other half, the plus 4. So here is multiplying your inners and your last. So essentially we're saying we're multiplying the plus 4 to the 3a minus 4. So that's going to give me 4 to the 3a is plus 12a. And 4 to the minus 4 is going to give me minus 16. Notice how I'm being strategic about the way that I lined up my work. I'm using that vertical method that we used for addition and subtraction previously. And I really like this, especially for this question, because now we can see the minus 12a and the plus 12a are like terms. And when we simplify them, they are eliminated. So we are left with 9a squared minus 16. Okay, this type of polynomial has a special name, and that special name is what we call a difference of squares. Okay, the reason why it's called a difference of squares is because 9a squared is a perfect square, 16 is a perfect square, and we're subtracting perfect squares. So I want to look at this pattern again on a separate page. All right, so here I gave you the pattern. Whenever we have the pattern of multiplying a plus b to a minus b, the result is going to be what we call a difference of squares, a squared minus b squared. So I want to point out just some more vocabulary. The a plus b and the a minus b, that is what we call conjugates, right? So 3a plus 4 and 3a minus 4, those factors, these are conjugates. And then the result, what we get when we multiply this out, will be the difference of squares. The a squared minus the b squared. So I want to do this question again because sometimes it's helpful to see how to implement a shortcut if you so chose to do so. So in this question, I can see I have conjugates and I know it's going to fulfill this pattern. So I know based on the pattern, capital A is 3A and capital B is 4. So this is saying when you're multiplying conjugates, it's going to equal the square of A. So I'm going to put in parentheses 3A squared minus, and then the square of B. B is 4, so 4 squared. So when we square 3A, we get 3 squared, which is 9, and then A squared, minus, and then 4 squared, which is 16. Which is the same answer that we got on the previous page, right? We have 9a squared minus 16. So you basically have two ways to attack this type of question. You can just straight multiply, or you can use the formula shortcut. It's really up to you which way you use. Just know that if you use the shortcut, make sure you implement it correctly. All right, here's another special polynomial. This one is, the result is going to be a perfect square trinomial. So it says here at the top, two different perfect square trinomials that you can get, one involving the square of a plus b and the other involving the square of a minus b. So in this example, we have the square of something that would represent a minus b. But I am going to do this question just straight multiplying, okay? So that we have practice with that. But I do want to caution you, caution, caution, caution. The square of 3w minus 4 does not equal 9w squared plus 16. Okay, that makes me very sad when I see that, okay? So I think why that happens is students try to distribute an exponent across subtraction, and you cannot distribute an exponent across subtraction. You can distribute an exponent across multiplication, but this is an exponent that's outside of parentheses, and inside of parentheses, there's subtraction. So let's expand this question. We have the square of 3w minus 4, which means we have 3w minus 4 in parentheses, multiplied to parentheses, 3w minus 4. That's what that expands to. So now, as we saw before, I'm going to distribute the 3W there and there, or essentially, I like to show my work. 3W, I'm multiplying to the 3W minus 4 first. So that's going to give me 9W squared minus 12W for the first half. Okay, let's distribute the minus 4 here and there. So essentially, I'm distributing minus 4 to the 3W minus 4. So that gives me, again, minus 12W plus 16. Notice again, I'm being clever with the way that I write my 4 terms, aligning my like terms vertically. Now, starting with 9W squared, I'm just going to bring that down. The minus 12W and the minus 12W does not eliminate. They are both negative, so you add them and you keep the negative sign. So we have negative 24W and then bring down the plus 16. And this, folks, is our answer. And this answer is a perfect square trinomial. So, as always, I'd like you to try one. Here we have parentheses, 5c squared minus 6d, close parentheses, squared. Pause the video, try that on your own. If you want to try to use the formula, you can, and then we'll do it together. Okay, so I'm going to do this question twice. The first time I'm going to just multiply this out because it's important to have that skill down. So remember, this expands to parentheses 5c squared minus 6d, close parentheses, parentheses, 5c squared minus 6d, close parentheses. So we're distributing the 5c squared there and there, which means we are doing 5c squared multiplied to the 5c squared minus the 6d. And that's going to give us 25c to the 4th minus 30c squared d. Okay, let's keep distributing. The minus 6d there and there, essentially we're doing minus 6d multiplied to 5c squared minus 6d. All right, so that's going to give us, again, minus 6d to the 5c squared gives us minus 30c squared d. And then the minus 6d multiplied to the minus 6d gives us plus 36d squared. Okay. Let's simplify. So I'll bring down the 25c to the 4th. And then the minus 30 and the minus 30, add them. So you get minus 60 c squared d. Add your coefficients, not the variables or the exponents, okay? When you're combining like terms. And then bring down the plus 36d squared. All right. So let's try this again, but this time, let's see if we can use the formula. Oops. All right, here we go. We're going to use the formula. So we're going to do it again. And looking at the second formula, we have a difference of A and B. So A, capital A, represents 5c squared, and capital B represents 6d. So the formula says to square A, so parentheses 5c squared minus 2 times capital A, which is 5c squared, times B, which is 6d, plus, and then square B. So that's 6d, close parentheses, squared. All right, so now if we simplify this, when we square 5c squared, we get 25 c to the fourth minus 2 times 5 is 10, and then 10 times 6 is 60, and then we have c squared d plus squaring 6d, so we get 36 d squared. All right, and so this should match what we got previously. All right, and it does. All right, so you can use, do them either way. It's just that you're not gonna be given these formulas when you're taking your test and your exams. You would have to memorize it. So it's actually less work to just remember how to multiply as opposed to trying to keep all these different formulas in your head. Okay, so now these are just harder questions. We already got the basics down. So we have parentheses 3x plus 1, close parentheses, times parentheses 5x squared plus 2x minus 6, close parentheses. So at this point, we see we have two terms in the first set of parentheses multiplied to 3 terms in the second set. All right, so just as a mental note, 2 times 3 gives me 6 terms. All right, so I like to recall that so that I know that I have not skipped any step in my distribution. I should get 6 terms before I simplify. So let's go ahead and distribute the 3x there, there, and there. So we have 3x times the 5x squared. So that gives me 15x cubed. Remember, you're adding your exponents. Okay, plus 3x times the 2x. So that gives me 6x squared. And then minus 3x times the 6. So that gives us 18x. Halfway there. All right, let's distribute the 1. That's going to be easy. So distributing a 1 to 5x squared plus 5x squared. 1 to 2x plus 2x. 1 to minus 6, minus 6. Again, notice how I lined up my work vertically here. So my like terms are easy to spot. So 6 terms before we combine like terms makes me feel good. Now bring down the 15x cubed and the plus 6x squared plus 5x squared. Add your coefficients, plus 11, and then we have x squared. Next, minus 18x plus 2x. Subtract your coefficients, so we have minus 16x, and then bring down the minus 6. All right, this next one, we have 3 terms times 3 terms. A big one here, 3 times 3, which means we should get 9 terms before we simplify. So go ahead, pause the video, try this one on your own, and then we'll do it together. All right, let's do it. So I'll start with distributing the z squared there, there, there. All right. So z squared times 3z squared gives me 3z to the fourth. Z squared to the minus z gives me minus z cubed. Z squared times the minus 5 gives me minus 5z squared. Awesome. Let's do the next one. Plus 3z distributed there, there, there. All right, 3z multiplied to 3z squared is plus 9z cubed. 3z multiplied to the minus 1z gives me minus 3z squared. And 3z multiplied to the minus 5 gives me minus 15z. All right, and then distribute the minus 2. There, there, and there. All right, so minus 2 multiplied to the 3z squared is minus 6z squared. Minus 2 multiplied to the minus z gives me plus 2z. And then minus 2 multiplied to the minus 5 gives me plus 10. All right, so we have 9 terms. Perfect. Now let's go ahead and simplify. So I'll bring down the 3z to the fourth. Then the minus 1z cubed plus 9z cubed. Subtract your coefficients, so that gives us plus 8z cubed. All right, minus 5z squared, minus 3z squared, minus 6z squared. You're adding your coefficients here, but you end up with a negative still. So we have minus, and then the 5 and the 3 is 8, and then 8 and the 6, we have 14z squared. All right, minus 15z plus 2z, subtract your coefficients. So we have minus 13z and bring down the plus 10. All right, this question, that was a big one. And sometimes it's helpful to have different methods of organizing your work. So I'm gonna redo the question we just did using a method I like to refer to as the box method. And it's really just for organizational purposes. So I'm gonna make this box have 3 columns and 3 rows because each group of our parentheses has 3 terms. So that's why it's 3 by 3. I'm going to write the first set of parentheses, I'm going to write along the left side. So I have z squared, and then the positive 3z, and then the minus 2. Along the top, I'm going to put the second set of parentheses. So we have 3z squared, the negative z, and the negative 5. It doesn't matter if you were to reverse these, it's going to give you the same result. All right, now I'm going to use this box as a guide. So in this first corner, I'm multiplying the z squared times the 3z squared, which gives me 3z to the fourth. Next, I'm going to multiply z squared times the minus z. So that gives me minus z cubed. Then the z squared times the minus 5. So that gives me minus 5z squared. All right, 3z times 3z squared. So that's going to give me positive 9z cubed. 3z times the negative z, so that's going to give me negative 3z squared. And then 3z times the minus 5, so that's going to give me negative 15z. Last row, negative 2 times the 3z squared gives me minus 6z squared. Minus 2 times the negative z gives me plus 2z. And the minus 2 times the minus 5 gives me positive 10. All right, so there you can see those were the 9 terms that we had previously, and you can now combine your like terms. So I can see we have 3z to the 4th as a loner. All right, then we have the negative 1z cubed and the 9z cubed. So that gives us a plus 8z cubed. All right, then the minus 5z squared and the minus 3z squared and the minus 6z squared. That gives us minus 14z squared. All right, and then we have the minus 15z and the plus 2z. So that gives us minus 13z. And then plus 10. And that should match our previous result. Right, that's what we had before. And that's what we had using the box method. So it's really up to you. You can use these for bigger questions, for smaller questions. If this were a binomial, which is 2 terms, multiplied by a binomial, which is 2 terms, then you would just create a box that was 2 by 2. So that's up to you. All right. Our last example for this segment, we have here 3 factors that we're multiplying. We have negative 3 multiplied to the x plus 2, which is then multiplied to the 2x minus 3. All right. Now, 1, when you're multiplying, you can only multiply 2 factors at a time. 2, when you multiply, you can, the order in which you multiply can be rearranged. So that's based on your preference. So first, I'm just going to multiply starting with the negative 3, and then I'll multiply that through to the x plus 2. And then whatever I get as that result, then I'll multiply that to the 2x minus 3. So again, you have to multiply 2 factors at a time. So I'm starting with the negative 3 to the x, which gives me negative 3x. And then the negative 3 to the positive 2, which gives me minus 6. Now I'm going to take that result and multiply it to the 2x minus 3. Right, so this just gets brought down. All right, so now I can distribute the negative 3x to the 2x and to the minus 3. So that gives me negative 6x squared plus 9x. All right, distribute the minus 6 to the 2x minus 3. So that gives me minus 12x plus 18. Again, notice how I'm organizing my work. So my like terms are lined up vertically. So now simplify this and we bring down the negative 6x squared. The 9x minus 12x, subtract your exponent. So we have minus 3x and then bring down the plus 18. Done. Okay, this time I'm going to redo this question and instead of multiplying the -3 and the x plus 2 first, I'm going to choose to multiply the x plus 2 to the 2x minus 3 first. So that means I'm going to begin with distributing the x to the 2x and to the minus 3. So that's going to give me 2x squared minus 3x, and then distribute the plus 2 to the 2x and to the minus 3. So that gives me plus 4x minus 6. I'm going to simplify this. 2x squared, and then the minus 3x and the plus 4x gives me plus 1x minus 6. Okay, so the result of that, I want to multiply to the -3. All right, so now I'm going to distribute the -3 to the 2x squared, to the 1x, and to the minus 6. And that gives me minus 6x squared minus 3x, and then plus 18. As you can see here, we got the same result. Now, my preference is actually the way that I did it on the right side. And the reason why I like that is because I like to keep the coefficients as small as possible until the end. And so I would have preferred to wait until the very end to distribute the -3. But it doesn't matter which method you pick, which order in which you multiply, shall I say. Just remember, you can multiply 2 factors at a time, take that result, and then multiply it to the next factor.